Hello guys, in our previous video we have seen about the pressure loss due to friction. In this video we will solve some numerical and then learn about the some concept. So moving towards the numerical is about a duct of 15-meter length passes air at the rate of 90 meter cube per minute. Assuming the friction factor as 0.005, calculate the pressure drop in the duct in mm of water. When the duct is circular with a diameter of 0.3 meter and the duct is of 0.3 meter square cross section. So here we are having the value of volume flow rate, mass flow rate, length. Then we are having the friction factor is given is 0.005. Then we have to calculate the pressure drop. So L we are having, Q we are having, then we are having F. So we have to calculate the friction factor. So the friction loss. Pressure drop in a circular duct due to friction. For the circular duct, we are having diameter is 0.3 meter given. So cross section area is 0.07 meter square. Then velocity of air passing through the duct is V is equals to Q upon A. So velocity we got as 21.4 meter per second. And weighted perimeter of duct P is pi d is 0.94 meter. So hydraulic mean depth is A upon P. We get hydraulic mean depth as 0.074 meter. We know that the pressure drop in a duct is given by formula Pf is equals to Fl upon m multiplied by V upon 4.04 into whole square. This formula is taken because we want to calculate in the term of mm of water. So put in the values. After the putting all the values, we get Pf is equals to 28.47 mm of water. So similarly, we have to do for the rectangular duct. Here cross section area is 0.09 meter square and V we got as 16.67 meter per second in perimeter, and after that hydraulic mean depth is we get as 0.075. Now putting all the values we get 17.02 mm of water. So in this way we can solve the numerical based on this situation. It was a simple numerical, so we can solve it easily. Now moving towards the next point, which is friction factor for ducts. In the previous numerical, we have given that value of F, which is small f, that is called as friction factor. So now we will see what is actually a friction factor is. For the laminar flow, the friction factor is given by 64 upon Rn. Rn is a Reynolds number. So in this way, we can get the friction factor. If we have the Reynolds number instead of friction factor, so we can get friction factor by 64 divided by Reynolds number. And if we are having the turbulent flow, then friction factor is given at 0.3164 divided by Reynolds number raised to 0.25. So Rn, so we all know that the Reynolds number is inertia force upon viscous force. So if after the simplification we get dV upon k. D is a characteristic length. So now after the knowing the friction factor, moving toward our next topic, which is equivalent diameter of a circular duct or rectangular duct. So if we are having the if we are given the diameter of a circular duct, so how we can get area for the rectangular duct, that is to be fine. Here we are having the derivation given, so we will see how we get that. The equivalent diameter is the diameter of a circular duct or a pipe that gives the same pressure loss as equivalent rectangular duct or pipe. So this is the basic definition of equivalent diameter. So in order to find the equivalent diameter of a circular duct for a rectangular duct for the same pressure loss per unit length, we consider following two cases. Two cases are there. A is when the quantity of air passing through the rectangular and circular duct is same, and when the velocity is same. These are the two cases here. We'll see one by one. The first case is when the quantity of air passing through the ducts is same, means Q is same. Let Q is a quantity of air passing through the rectangular and circular duct, which is same. So we have taken Q directly. Now A is a longer side of a rectangular duct, B is a shorter side of a rectangular duct. D is the equivalent diameter of a circular duct. Now AR is a cross section area of rectangular duct, which is given by A into B. PR is a weighted perimeter, which is 2 into A plus B. AC is a cross section area of equivalent circular diameter, which is pi by 4 d square. PC is weighted perimeter, pi d, and PA is a mass density. Sorry, rho A is a mass density of air. These are the terms. Now, how we can solve? Velocity of air passing through the circular duct, we know V is equals to Q upon A, and for the similarly for the circular duct, for the rectangular duct, VR is equals to Q upon AR. Here Q is equals to same, Q is same, so we can equate both the terms, term 1 and term 2. So we get PF is equals to, we know that PF is equals to FL rho V square upon 2M, and we can separate, we can put the value of V is equals to Q upon A. So we get FL rho A upon 2M multiplied by Q upon A whole square. Now we know that the V is equals to Q upon A. So we have put it into equation. After the substituting, we get the pressure loss due to friction for the circular duct. PFC is equals to FL rho A Q square by 2 multiplied by PC upon AC Q. Because here we put the value of P upon AC, and when there is a V, so we have put it into Q upon A. So we get it PC upon AC Q. And the pressure loss due to friction for the rectangular duct. For the same, we get FL rho A Q square upon 2 multiplied by PR upon AR cube. Since the pressure loss, friction factor, length, density, and quantity of air for the circular and rectangular same, so we can cancel out terms. Therefore, the above equation we can put into relationship. So we get P upon AC whole cube is equals to PR upon AR whole cube. So now PC upon AC whole cube, PR upon AR whole cube. Put the value of perimeter and area, and after the simplification and solving the mathematics, we get the T is equals to 1.265 into bracket a cube b cube upon a plus b whole square raised to 1 by 5 whole raised to 1 by 5. And this is the equivalent diameter. So if we are having the area of rectangle, means if length and width is given, and if question asks that find for the circular diameter, so we can get easily value of d. If we are having A and B, so for the same pressure, we can easily find out the cross section or diameter of a circular duct. So this is the very useful formula. Now our second case was when the velocity of air passing through the rectangular and circular duct is same. In previous case, quantity of air was same, and now in this case, V is same. Now in the previous, we have taken V1 and V2. Now in this case, we will take simply V, and we will defer the quantity. Now let the V of a air, V is a velocity of air passing through the rectangular and circular duct. We know that the pressure loss due to friction for the circular duct is a PFC is equals to FL rho A V square upon 2. Now pressure loss due to friction for circular and rectangular duct we got. Now we just have to put into or equate them. So we get PC upon AC is equals to PR upon AR. As velocities are same, so we can cancel out in both terms. Now we have to just put perimeter and area. So we can get D is equals to 2A upon A divided by B plus 1. So A by B is also known as aspect ratio of a rectangle. In this way, we can get the value of D when we are having value of A and B. So we can solve it. So this numerically we'll see in our next class. Up to this, we have covered the topics such as type of ducts, classification, and then Bernoulli's equation, how we can equate Bernoulli's equation. Then we have solved an example based on this, and then after that we have taken losses into ducts, friction loss, major loss, minor loss, and after that we have solved one more example based on the friction factor. And then in this lecture we have covered the uh, equivalent diameter of a circular and rectangular duct, and also some concept for friction factor. So that's all for now. So in the next video we will try to solve some example, so you'll get more clear idea about this concept. So thank you for now.